All right, guys, I got cut off on the last part, so I'm going to finish out 5A and then we're going to move on to part B. We have our equation in the quadratic formula. So we're pretty much going to just simplify this out. So I know my x is going to be equal to -2 plus, if I have 2 squared, that's going to be 4. And then I'm going to have -4 times 1 times -8, which is going to be positive 32. Okay. And if I add 4 and 32, I'm going to get positive 36. Okay. Then I have all of this over 2 times 1, which is just 2. Okay. So I'm going to continue to simplify this down. When you look at this, you should be able to see like, hey, this 36 is a perfect square. The square root of 36 is 6. So I'm going to have x equals -2 plus and minus 6 over 2. Then my last part, I have to consider both solutions. Remember, a quadratic can have up to 2 solutions. So one of my solutions will be with the plus sign. So I have x equals -2 plus 6 over 2. And then I have x equal -2 minus 6 over 2. Okay, so here, the first one is going to turn into 4 over 2, which means that x is equal to 2. All right, and then my second one, I'm going to have -2 minus 6, which is -8. That 8 is going to be, -8 is going to be over 2, so my x will be equal to -4. Again, excuse my handwriting. But your solutions are x equals 2 and x equals -4. All right, so let's go ahead and move on to part B. All right, so if you watched the video on part A, this should be pretty easy to you. We can use our calculator to find our key features, or if you want to find your key features by hand, you can do that as well. So I'm going to go ahead and type it into our TI Nspire. I'm going to clear this out by using DocB. And then I'm going to type in my equation. So we have y equals, which I don't need that because y equals and f of x is the same thing. So I have x squared minus 2x plus 3. Okay. So here's my graph. And I can do my trace feature using menu 5-1. And here's our y-intercept. So our y-intercept is 0, 3. Let's go ahead and write that down. And I'm just going to write it down as it comes to me. Okay. I'm going to keep going to the right. Here's our vertex, which is also our minimum point. And that's 1 and 2. So I'm going to write 1, 2. Remember, from that vertex, we know it's a minimum point, and then that minimum value is always the y value of your vertex, which is 2. And then for your axis of symmetry, it's always the x value of your vertex, and it's going to be an imaginary line that's going through the vertex. So that's going to be x equals 1. All right, and that's 1b. All right, 2b, they gave us a graph this time, so we want to find our key features. This time I can draw it in for you so you can see exactly what each key feature look like. So my axis of symmetry, again, we said it's our imaginary line that goes straight through our vertex and split our function in the middle. Okay. So if we look, it's crossing right through 0 on the x-axis. So it's going to be x equal 0 for our axis of symmetry. Okay. Here's my vertex. That's going through 0, 3. So I'm going to write 0, 3 for my vertex. Okay, this vertex is also our y-intercept. So sometimes they can share points. Okay, it's going through the y-axis. So that is our y-intercept. All right. For our solutions, zeros, x-intercept, and roots, we have 2 of them. They're not quite crossing exactly at a number, so I'm going to have to estimate. On the test tomorrow, most likely we will give you one where it's on the exact number. Okay. So our first one is really, really close to -2. So I'm going to say that this is maybe negative 1.7, comma 0. And this one here, again, is close to +2 this time. So I'm going to put 1.7, comma 0. Okay. Don't let the decimals confuse you. I'm just estimating somewhere between 1 and 2 and -2 and -1. Okay. Our vertex is at the top of the graph, so that makes it a maximum point. And our maximum value is going to be 3. Again, our max value always goes with our y value of our vertex, and that's the highest that our graph is going to go at 3. Domain is always real numbers. Again, that's going to keep going from the left and to the right, from negative infinity to positive infinity. So we're going to have all real numbers. In our range, remember, we want to look at our maximum or minimum value. In this case, it's a minimum value, which means it won't go any higher than that. So that means that my y values will be greater than or equal to 3. All right. All right, 3b, we're going to state our transformation from the parent function y equals x squared. If you watch part 1, remember you have 2 options. You can use your vertex form and see which letter does what, or you can type in both functions on a calculator and just observe whatever changes happened. Okay, so here, and I'm going to write my vertex form again right on top of it so I know what number goes with what letter. Okay, so with our a value being 4/5, that's going to be a vertical compression. Okay, in some cases, we want you to identify the number, so it'll be a vertical compression by 4/5. And I actually should have put this over here too. That is the vertical stretch by 2. Okay, if they ask for it, they may not ask, but if they do, there you go. My h is actually -6. Remember that formula is the opposite. Okay, so if I have +6, that means that I started with -6 and 2 negatives. You have to keep, change, flip, and that'll make a positive. Okay, so I'm going to have a horizontal shift to the left 6 units. Okay. Then my k is -3. So that's going to go down vertically 3 units. All right. With our vertex, remember we said that it's HK. So that's going to be here and here. Our H is always the opposite. So there's going to be -6 and -3. Okay, excuse my writing. All right. Now again, let's type this in the calculator so we can see what it looks like, just in case you forget what each transformation does. So my parent function is x squared. Then I'm going to press tab and enter in my function. I'm going to use control division to get my fraction bar. Then I have times x plus 6 squared minus 3. And let's see if it did what we just said. Okay. So we see we have a vertical compression because that graph did get wider. Okay. It did shift to the left 6 units. Okay. You see that from here to here. Vertex started off here at the origin, and now it's here at -6 and -3. Okay. And it also went down. Okay. So that's our graph. And then I can also trace my vertex if I want by using menu 5-1 just to double check. I'm going to press the up to get to the red one. And I'm going to scroll to my vertex like so. And there we go. -6 and -3. All right. Let's move on. All right, so standard form, again, we have ax squared plus bx plus c equals 0. So we have 7x squared equals 2x plus 5, and we want to get that to be in standard form. So we're really going to just move both of these terms over to the left side. So I'm going to start by subtracting 2x. And some of you might can just do it in your head and move it over. So I'm going to have 7x squared minus 2x. That cancels out over here. And then I still have this 5 over here. Then I'm also going to subtract 5 from both sides. And my final answer will be 7x squared minus 2x minus 5 equals 0. And that's our standard form equation. All right. Our next one, again, we're going to use the quadratic formula. So we have a equals 2, b equals -5, and c equals 3. Okay, we already have the formula written out on the first side. So let's go ahead and plug this in. I'm going to have x is equal to negative, and I have a -5 on the inside of those parentheses. Anytime you plug in a number, you want to use parentheses. That's kind of just like protocol for math. You know, we have those things. Then I have square root, -5 squared plus 4. Sorry, minus 4 times 2 times 3 all over 2a, which is times 2. Okay, so from here, this is going to turn into +5. Okay, then I have my plus minus. Okay, the square root part, I'm going to have -5 squared on the inside, which is 25. Okay, then I have 4 times 2, which is 8. And then I have 8 times 3, which is 24. We still have that minus sign, so I'm looking at 25 minus 24, which is 1. Then I still have over 2, 2 times 2, which is 4. Okay, then from here, let's go ahead and clean this up. So I have x equals 5. Our square root of 1 is just 1. So I'm going to have 1 with 5 plus 1 over 4. And then I'm going to have another one with 5 minus 1 over 4. So here, we're going to have 4, or 6 over 4, which is 3 over 2. And then I have 4 over 4, which is x equals 1. Sorry I rushed through that, but I wanted to